Hi, I'm Ariane Stern.
And I'm Peter Walsh.
This is our final project, the Elevation Sort Visualizer, an interactive tool that uses real-world elevation data to visually demonstrate sorting algorithms in action.
Sorting algorithms are core to computer science, but they're usually taught using abstract examples. Our goal is to make them more engaging by applying them to real elevation data. The users can see how sorting changes the structure of that data visually.
The data comes from NOAA's ETO-P01 Global Elevation Dataset, accessed through the Bridges API. At launch, the program asks for the number of rows and columns, and we'll enter a 10 by 10 grid here. This will give us 100 real elevation points, each with a latitude, longitude, and elevation value. And once the data loads, it's visualized as a heat map using Matplotlib. This shows the original spatial layout of elevation data before any sorting. This step helps users get a sense of how elevations are distributed across the selected region. Then the data is passed to our Pygame visualizer. Each vertical bar represents one data point, and the color corresponds to elevation. At the top, we have buttons to choose from 6 different sorting algorithms. We implemented bubble selection, insertion, merge, quick, and heap sort. Each one animates in real time and shows exactly how the data is being rearranged. Let's run it through a couple of them now. Here's merge sort first, and you can see the bars being compared and swapped step by step. Once the sort is complete, we'll show a side-by-side heat map comparison, original on the left and sorted on the right. And this clearly illustrates how sorting affects the structure of elevation data when it's mapped visually. Additionally, we added 3 color themes: terrain, grayscale, and heat map, and you can switch between them by pressing the C key. You could also hover over any bar to view its exact latitude, longitude, and elevation. We also added keyboard controls such as R, which resets the data with a new data set, S, which shuffles the current data set, and the escape key, which will allow you to exit the program. These shortcuts make it easier to explore and experiment with different sorting scenarios. We're going to show another sort right now. This is heap sort. And at the top left of the screen, once it's done sorting, it'll show a summary of the lowest, median, and highest elevation values. And these update live anytime the data changes, whether it's sorted, shuffled, or reset. Additionally, it'll show the sort time and the amount of comparisons and swaps that were made while sorting the data. This project gives us a great opportunity to tie algorithm concepts to real data in a visual and interactive way.
We hope it helps others learn how sorting algorithms work and how they can apply to data sets beyond just numbers.
Thanks for watching, and as we conclude this video, Peter is going to shuffle through some of our other sorts. Here's insertion sort. Next, we're going to do quick sort.